This is lesson 231, triangle inequality. All right, so the triangle to our right is a right triangle. That means that it makes, two of its sides make a right angle. So I'm looking here, that's side AB and side CB, okay? And they want us to estimate the length of the hypotenuse, okay? Just estimating here. This side, right down here is 1, 2, 3, 4, 5, 6, 7 squares. This side is 2. Okay, if we wanted to estimate, there's a couple different options here. There's no super wrong answers, okay? But this is going to be around a little over 7. So your teammate decided to repeatedly rotate the triangle on the graph. So here's this triangle, okay? And what they did is they took it and they rotated it over here. And then they rotated it over here. And then they rotated it again like this until they made a square with all those rotations of that same triangle, okay? We've got 2 squares here. We've got the outside square, this big one that we made, okay? But when we rotated these triangles, we also made this inside square as well, okay? So 2 squares here. The change in y over on this triangle is 2, and the change in x is 7. So let's go ahead and label these. Okay, so 2, 7, 2, 7. Whoops, I have those mixed up. Or no, I guess the graph actually has this mixed up. So let's switch those. It doesn't really matter which one is which, because each side has a change in y and a change in x. So each side has a length of 9. So the area of the big square is 9 times 9, which is 81. Okay? Now we said this was a little over 7. Let's say 7.2 or something. Okay? That's the hypotenuse of each triangle. So let's say 7.2, 7.2. Okay? So base and height of that small triangle, 7.2 times 7.2 is about 51.84. Okay, so what we're trying to figure out here is basically how long can we make a missing side of the triangle. Okay, when we are kind of guessing, when we don't know what it is, when we guess maybe 7.2, we want to figure out, okay, what are all our possible guesses that would work, okay? So, 4 different triangle, ABC, let's make ABC. AB is 3 units, so AB, that's 3 units. BC is 4. And then we need to figure out, or it says our teammate claimed that AC is 25. Oh my gosh, if we somehow made that 25, okay? Again, that's a rough estimate. Could we make this into a triangle, okay? And my guess is no, because the 3 and the 4 to somehow split between this 25 and make a triangle out of that, I don't think you can make 3 and 4 do that in any way. So my guess is that this is not possible for that extra side to be 24 or 25. So we actually have something called the triangle inequality theorem. Okay, so we have this e-tool that you might use in class. Okay, so let's try this. If one of our sides is 3 and one of our sides is 4, whoops, 4, honestly 4.1 is good enough. Can the other side be 25? Let's get that up to 25. Is there any way that we can make these into a triangle? No, absolutely not. This does not work. Okay, so what could it be? Let's see if I can get this to, there we go. So let's see what it could be. Okay, maybe it could be, oh, now I'm moving everything here. Okay, it could be 5. And there's a couple other things that it could be. Okay, so we've got something called the triangle inequality theorem, where we're gonna determine if these sides are possible. Okay, so when we play around with these tools here, A and D do not end up producing triangles when we play around with this tool. Okay, so it usually means because one of the sides is too long or too short. So the triangle inequality theorem, I guess let's put that right here. Triangle inequality theorem. So let's maybe write that right here, the triangle inequality theorem. Okay. The longest side okay, the sum of the two shortest sides sum means to add, so if we add up the two shortest sides, that has to be greater than the longest side. So the sum of the two shortest sides must be greater than the longer side. Okay, so if two sides of a triangle were 4 and 12, what's the longest the third
All right,
could
if
be?
two
Or, I'm
sides
sorry,
of a
5 and 12,
triangle were
what's the
5
longest the
centimeters and
third
12
side could be?
centimeters long.
Okay, so if
Okay,
5
so
and
let's
12
say
are our
like
two
that,
shortest.
5 and 12. What is the longest the third side could be?
We have to add
Okay, so
those
remember
up.
that
So that's
these
17.
two, the shorter
So
sides,
our
when we
side
add
has
them
to
up,
be longer than
they have
17.
to be greater than
Okay.
the longest side. So
However,
let's put the greater than
what-
symbol. Those two added must be
Here, let me say
greater than
longer
the
than
third
17.
side. Let's call the third side
However,
X.
what if
Okay,
12
so
was the
5
longest
plus
side?
12 is 17.
Okay, what if that was the longest
Okay,
one?
so X has to be less than
So
17.
5 plus our missing
in order
side.
for the shorter sides
Let's
to
call that
add
X.
up to more than that. So our answer is the longest it can be.
Those have
is
to
less
be,
than
let's say,
17.
less than,
Okay. What is
12.
the shortest it could be?
right, because the
Okay.
two shortest
What
sides.
if instead with our 5 and 12?
Or, I'm sorry. Must be greater than 12.
What if
the two
12
shortest
was
sides
the
have to be
longest
greater
side?
than 12?
Okay, so
So
what if this
if we
third
subtracted
side
5 from both
was shorter?
sides,
So now 5 plus our mystery side should be more than the third side, right? Let's say 12 is the longest now. The third side, if we subtract 5, can be greater, or must be greater than 7, right? So the shortest it could be is just a little more than 7. So the shortest it can be is greater than 7. It can't be 7 exactly, right? Because the two sides added up have to be more than 7. But literally even 7.0001, that could work. All right, let's find the maximum and minimum limits for each missing side length of the triangles below. So here, 13 and 19, if we add them up, they have to be greater than this missing side. Okay, so that's going to be 32. X has to be less than 32. But what if this picture isn't going to make sense?
At this time, students with the last names A through Z that would like their photo retaken or have not yet taken their photo this year may now report to the auditorium. This is last call for photos for retake day. Thank you.
But what if 19 was the largest side? Right, so let's move this 19 over here, okay, and make that x. Okay, so now 13 and x have to be greater than 19. So if we subtract 13 from both sides, x has to be greater than 6. Okay, so here are the limits, okay? X has to be greater than 6, but less than 32. Those are the options for that triangle. So let's do it again for this one. 14 and 15, let's assume those are the shortest. So 14 plus 15 have to be more than x in order for that to be a triangle. So x has to be greater than 29. However, what if we assumed that 15 was the longest side? Okay, so now 14 plus x, those are the two shorter sides now. Those have to be more than 15, our longest side. We could subtract 14 from both sides. X has to be greater than 1. So here is our limits for what the sides of this triangle could be. X has to be greater than 1, but less than 29. Has to be in between those two. Okay, and then finally, let's call this B. So if A and C were the shortest sides, A plus C has to be greater than B. Okay, or let's say A was the longest side, then C plus B has to be greater than A, or maybe C is the longest side, so then A plus B have to be greater than C. Okay, so there's a couple different things that could be there. So if we fill these out, our maximum length is little under 32, less than 32. Minimum length, that has to be greater than 6. Okay, maximum length for this second one had to be less than 29 and greater than 1. And then here we've just got a lot going on. So with our key concepts, a way to remind ourselves how to find the maximum lengths, okay? For the max, that's going to be side 1 plus side 2 have to be greater than x. And for the minimum, you're assuming that side 1 and x are the smallest, and that has to be greater than side 2.
Moving on to the mild section, is it possible to have a triangle with these given side lengths? We just need to make sure that the two smallest add up to more than the largest, and 13 plus 14 is going to get us 27. That is definitely bigger than 19, so this is good to go. Yes, this is a triangle. Okay, 6 and 9 make 15. However, we have to be longer than the longest side. These are the same, so this is not going to work. 3 and 3 add up to 6, which is not good. That's not going to work. 6 and 9 add up to 15. This is more than 12, so yes, this can be a triangle. 1 and 2 add up to 3, which is the same as 3. This is not going to make a triangle. All right, in triangle ABC, AB is 5, BC is 3. So which of the choices represent all the values, okay? So if 5 and 3 were the shortest, that means the longest side has to be more than 8, okay? Or I'm sorry, the longest side has to be less than 8. It can't be equal to 8, so we're going to cross that out. Okay, but it could be a little bit, it could be more than 7, right? It could be 7.999. So here's our answer here. We can make sure that 2 is the correct option. Let's pretend that 5 is actually the longest side. So we have to make sure that 3 plus the other side AC is going to be more than 5. So x has to be more than 2, which is what we have here. So yes, that is correct. All right, the 3 numbers, if they can be measures of a triangle, 4 and 5 make 9, which is more than 7, so yes.
2 and 4 make 6, which is more than 5. That one's good to go. 3 and 2 make 5, which is not more than 6. So that one is not going to be a triangle. And then 8 and 2 add up to 10, which is good. This is longer than our longest side, so that can be a triangle. Moving on to the medium section, we have this triangle where side YX, so that's this side, is 10, XZ is 7, and then what is the greatest and least possible whole numbers, okay? So first, we could pretend like these are the shorter sides, so 10 plus 7 is 17. So this longer side has to be greater than 17. Oh my gosh, I'm sorry. This longest side has to be less than 17, right? Because these two sides added together have to be greater than the longest. Let's call this X right here. So X has to be less than 17. It can't be any bigger or else these two sides wouldn't reach. We could assume though that 10 would be the longest side, okay? Obviously not according to this picture, but if 10 was the longest side, we need to make sure that 7 plus the missing side would be greater than 10. So if we subtract 7 from both sides, X must be greater than 3. So here are the possible options. X can be greater than 3 or less than 17. Okay, we've got triangle dog here. What is a possible value for CO? All right, this one, let's see. If this is the longest side, well, actually, let's check these. If this was 4, this would be 7 and 5, which 7 plus 5 equals 12. We would need that to be bigger than the longest side. So 4 is not going to work for us. Okay. If we tried 11, then this side would be 14. So now that's the longest side. We have to make sure that 5 and 12 add up to more than 14. But that obviously doesn't work. So 11 is not going to be any good. If we plug in 14, okay, 14 plus 3 is 17. We have to make sure that the two shortest sides, 5 plus 12, should be greater than 17. However, this is equal to 17, so that is also not going to be good. So let's try our final one, 15. Okay, 15 plus 3 is 18, so that side is 18. We just have to make sure 5 plus 12 is greater than 18. 5 plus 12 is not greater than 18, okay? Let's try 11 here. 3 plus 11 is 14, so that's our longest side. So we just have to make sure 5 plus 12 is greater than 14. 5 plus 12 is 17. Okay, so that would work. We could use 11. Okay, which two sides of the triangle have the following measures? We're going to find the range. Okay, so if these were the two smallest, 9 plus 5, the third side has to be smaller than 9 plus 5, that is 14. Okay, so smaller than 14. But if 9 was the biggest side, 5 plus our missing side would have to be greater than 9. Subtract 5 from both sides, so x would have to be greater than 4. So if we're writing that, x has to be greater than 4 and less than 14. Here with 6 and 10, if these are the two shortest sides, then the missing side has to be less than those two added together, so less than 16. But if 10 is the longest, 6 plus the missing side has to be greater than 10. Subtract 6 from both sides. The missing side has to be greater than 4. Okay, so there we go. 5 and 8, if these are the shortest sides, the longest side has to be shorter than 5 plus 8, which is 13. But if 8 is the longest side, then 5 plus the missing side has to be greater than 8. Subtract 5 from both sides, x has to be greater than 3. And then finally, if 6 and 9 are the smallest sides, x has to be less than those two added together, which is 15. And then if 9 is the longest side, 6 plus the missing side, those have to be greater than 6. So x has to be greater than 0. On to spicy. Okay, triangle TAB has a perimeter of 40 centimeters. Could the measure of the sides, as shown, actually represent the measures of the sides of the triangle? Okay, so let's see here. First of all, we're going to need to find x. So let's add all of these up. 4x plus x plus 3 plus 2x plus 2. Those should add up to 40. If I combine all the x's, I'm going to have 7x plus 5 equals 40. So that x equals 5. Okay, so let's plug 5 in for x then. So the side would be 20 if we plugged in 5 for x. Plug in 5 for x, this side is 8. And then plugging in 5 for x, we're going to have 12 here. Okay, so 28 and 12, is this possible? Well, we need to make sure that the two smallest sides add up to more than the bigger side. So does 12 plus 8 end up being more than 20? And that is no. 12 plus 8 is 20, and we need it to be more than 20. So this is not possible. All right, the lengths of the sides of a triangle are 8 and 12. Okay. The length of the third side must be between what two numbers? So they're asking for the range again. So if 8 and 12 are the smallest, the longest side must be less than that. So x has to be less than 20. But if 12 is the biggest side, then 8 plus our missing side has to be greater than 12. So x has to be greater than 4. Okay, so here's our range. And they want us to repeat with the other side lengths and write a generalization for sides of lengths A and B, where B is the bigger one. Okay, so to generalize this, if A and B are the shortest, we know that x has to be less than A and B. Or if B is the longest, then A plus x has to be greater than B. Okay, so what we can do is x has to be, I'm just rewriting this into one statement over here. X has to be less than A plus B, but greater than B minus A, excuse me, because we'd subtract an A from both sides here. So x has to be greater than B minus A. There is our generalization. Okay? And then again, we're going to test these triangles, but this is actually the same problem as down here, so those answers can be found above.